In order to understand the concept of point of contraflexure and points of zero shear force, consider the example as shown. Consider people having weights 50 kilograms, 80 kilograms and 40 kilograms occupying positions on the key as shown. If the free body diagram of the system is considered, the forces act on the key as shown. If the width of the key is small, as compared to its length, then the moments due to forces F1, F2, and F3 can be neglected. And, thus the 3D system can be converted into a planar system as shown. Assuming the gravitational constant, g, equal to 10 meters per second square, the shear force and bending moment diagrams, with values tabulated for the same, are shown in Table 1 and Table 2 respectively. For an equation of bending moment, m being the independent variable, and the position x being the dependent variable in a function f, the equation dm by dx equal to 0, corresponds to either a local maximum or local minimum in differential calculus. Points of zero shear force help in identifying positions of maximum bending moment, which enables designers whether additional structural reinforcement is required. Consider a point F on the bending moment diagram, where the bending moment changes its nature from sagging to hogging, if it is traced from end A. The point F is called the point of contraflexure. At the point of contraflexure, the bending moment m becomes 0. Knowledge of the point of contraflexure is important in the design of reinforced cement concrete, which in turn are used in bridges.